Okay, we're going to keep talking about our trig functions, and today we're going to learn how to find the trig values for any angle. So we're going to start by letting theta be an angle in standard position. So that means if you look down at our picture, standard position means the positive x-axis is one side of the angle, and the other side of the angle is here in the first quadrant. So that's our standard position with xy as a point on the terminal side of theta. So this is our point xy, and that's just some point, right? It could look like this. It could be have some angle, and there's a point right here, and say that's the point 2 comma 5. So that's all we're talking about. So when that's the case, so we have an x value and a y value, they kind of make this right triangle, because if you were going to go from the origin 0, 0 and go to this point xy, you would go over x and up y. So that x and that y can be used to find this distance, the hypotenuse, which in a circle is called the radius. And the way we find that quickly by using the Pythagorean theorem, so the idea that x squared plus y squared equals r squared can translate to r equals the square root of x squared plus y squared. So very quickly we can find out the radius of these circles and how long these hypotenuse are. And this same idea, this triangle, extends down into the third quadrant like this. So we have a nice triangle right here. So this would be negative x and negative y. Or we could extend it and go this way. Bring that up there. We still have negative x, but now we went positive y. And we could also go down this way, have some point here. All right, so it'd still be positive x that we have right here, and this would be negative y. So just think about that. It's nothing you need to master today. But let's start with just our original theta, just the red triangle I have drawn here. So the sine of theta is going to be the opposite over the hypotenuse. So that's going to be y over r. The cosine is going to be the adjacent, x over r. And the tangent is going to be the opposite over the adjacent. And then our other three, cosecant is going to be r over y, secant is going to be r over x, and cotangent is x over y. And these are things that we want to be able to memorize, or at least figure out quickly, because a lot of times we're going to be given a point, an x and a y, and asked to find the sine, cosine, or tangent based on that point. So looking back up here, it can be kind of confusing when I started talking about negative x and negative y, or positive x and negative y, because that would mean that the tangent over here, when tangent is y over x, well, sometimes if we went into this green one, into the second quadrant, the tangent would be y over negative x, which would make it negative, right? If we have a positive over a negative, that makes a negative. So when we're in our coordinate plane, this little mnemonic, all students take calculus, can help us remember which trig functions are positive and where. So I'm going to go ahead and label this. Quadrant 1 is A, quadrant 2 is S, quadrant 3 is T, and quadrant 4 is C. And so our little acronym or mnemonic, all students take calculus, will help us out here. In the first quadrant, just like with points, the x is positive, the y is positive, and that's going to result in the sine being positive, cosine being positive, and the tangent being positive. If we go to the second quadrant now, the x values are negative and the y values are positive. So what that's going to result in, if we have a negative x and a positive y, if you look back up here, our sine is still going to be positive because it's going to be y over r. And something to add here, r is always positive. Okay, R is always positive because R is a distance. It's the radius. So R is always positive. So sine will be positive because y over r is positive over positive. Cosine will be negative because it's going to be x over r, so negative over positive. And tangent will also be negative because tangent is y over x, so positive over negative. We come down into our third quadrant, so where our t is, and we get negative, negative. That's negative x's, negative y's. So that means that our sine will be negative, our cosine will be negative, but our tangent will be positive because it's negative over negative. And our last one, our fourth quadrant with the c, we get x values are positive, y values are negative. So what that translates to is our sine will be negative, our cosine will be positive, and our tangent will be negative. And what our little mnemonic tells us is that all students take calculus is a way of telling us which trig function is going to be positive in which quadrant. So here, it's all. In the second quadrant, it's only the sine function. In the third quadrant, it's only the tan function. And in the fourth quadrant, it is the cosine function. So if you look there, positive, 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 and in the first quadrant, they're all positive. So that's just something to help you as we move along. All right, so here's a quick example. Let negative 2 comma 9 be a point on the terminal side of an angle theta in standard position. So negative 2, 9. That is a point on the terminal side of an angle in standard position. Well, terminal side means, standard position means here's an angle, and that point is on the terminal side. Just like that. Find the exact value of the 6 trig functions. Well, if we look at the little right triangle that's formed here, this value, this side right here is 9. This is a nice right angle, and this is negative 2. Okay, so here's our angle theta, and we're going to use this triangle to help us figure it out. And this triangle will have the same trig values for this little angle. So we're going to figure out our sine of theta, which is going to be y over r. Our cosine of theta is going to be x over r. Our tangent is going to be y over x, and then our other three are just going to be the reciprocals of those. All right, so real quickly, we look over here. X is negative 2, y is 9. We need to find the r. So remember, the r is the square root of x squared plus y squared. So r equals the square root of x squared, negative 2 squared is 4, plus y squared, 81. So that's the square root of 85. Or we could simplify that a little bit, maybe, but we're not going to mess with it. We're just going to use it. So y over r is 9 over the square root of 85. So that just equals 9 square root of 85 over 85. X over r is negative 2 over the square root of 85, which equals negative 2 square root 85 over 85. All right, y over x, 9 over negative 2. R over y, square root of 85 over 9. R over x, square root of 85 over negative 2. And x over y is negative 2 over 9. So there's our 6 trig functions, and I promise you will get really fast at this. It won't take nearly as long as this is taken. Right, example 2, find the exact value of the 5 remaining trig functions. Well, let's don't do that. Let's just find the exact value of let's do the cosine of theta. So we have this tells us the cotangent of theta is -5/12, and sine of theta is less than 0. Well, cotangent, we know, is x over y, right? And sine, we know, is y over r. Well, this tells us that the sign is negative. And since the r is always positive, that means the y has to be negative, right? So when we look at this right here, it's -5/2/12. -5/12 is really +5/-12. So the x is positive, the y is negative to make that -5/12. Now we want to think about what that looks like in our coordinate plane. So the x is 5, y is -12. So it's going to look like this. But we have our nice right triangle here. Angle goes right there in the corner. X is 5, y is -12, and we want to find cosine. And we know that cosine is x over r, so we just need to find the r. R equals square root of x squared plus y squared. So r equals 5 squared plus -12 squared. So that's 25 plus 144, square root of 169, 13. So we can find that pretty quick. And also, if you remember, that's a 5, 12, 13 right triangle from geometry. So anyways, cosine of x over r, or cosine of theta, I'm sorry, equals x over r, which is 5/13. And this, again, I promise, is you're going to get really fast at this. All right, something else we're going to work with is called a reference angle. So a reference angle is the acute positive angle theta prime formed by the terminal side of theta and the horizontal axis, or the x-axis. So we got a quick picture here to look at. This will make this a lot easier. So it's the acute positive angle formed by the x-axis and the terminal side. So when our angle is in quadrant 1, here's an acute angle formed by the x-axis and the terminal side. So in this case, an angle in the first quadrant is its own reference angle. So remember, theta prime stands for reference angle, so this one's just going to be itself. No big deal. Just write that in both blanks. Itself. I don't know. All right, quadrant 2, here's our angle, 120 degrees. But we care about the acute angle formed by the x-axis and the terminal side. So that 60 degrees is our theta prime. And the way we find that is whenever we have an angle in the second quadrant, we do 180 minus theta. So our theta was 120. So 180 minus 120 equals 60. And that's how I know that's 60 degrees. If we're in radians, 180 and pi are the same thing. So we do 180 or pi minus theta. So this is for degrees. This is for radians. We're finding these reference angles because we're going to memorize values for the reference angles, and they're going to help us answer problems for all angles. All right, so let's say we're over in the third quadrant here with this guy. We're at 240 degrees. Well, the reference angle is 60, and that's because 240, we went 240 degrees past the 180 to here. Well, we'll just subtract the 180 out. So we minus 180. And that gives us 60, which is what's left. So 240 minus 180 gives us 60. And that's where that 60 comes from. 180, remember, is pi. So in radians, we do 180 minus pi. So this is degrees. This is radians. All right, quadrant 4. We've got a 315-degree angle, right? We went all the way around, almost to 360. In fact, if we had gone to 360, we could just subtract theta, and that would tell us what this is. So that's exactly what we're going to do. When we're in the 4th quadrant, we'll do 360 minus theta when we're in degrees, and 360 is 2 pi. So 2 pi minus theta when we're in radians. So 360 minus 315, that's where the 45 comes from. Not so bad. All right, a couple of quick examples and then we'll be done. So calculate reference angles for the following angles and sketch in standard position. All right, 300 degrees. Well, we know that if we're starting here, this is where we start. It's our initial side. We're going to go 300 degrees. So we're going to go 90, 180, 270, plus 30 more, right? So that is 300 degrees. But we want to calculate our reference angle. Our reference angle is this angle. It's pretty easy. We just do 360 minus 300, 60. So theta prime equals 60 degrees. All right, we'll come over here to this one. 2.3 radians. Well, I don't know what that is. So I'm going to multiply it by 180 over pi to convert it to degrees. And I get about 132 degrees. So start here with my initial side. I'm going to open 90, not all the way to 180, right? Halfway would be 45 degrees here, so 90 plus 45 is 135. So just about halfway there is where it's going to be. So here's my angle. It opened 2.3 radians. But what I'm interested in is this. This is my theta prime. And the way we find that, theta prime, when we're in the 2nd quadrant, is we do pi minus theta. So pi minus 2.3. So in your calculator, pi minus 2.3 is 0.84. So theta prime is 0.84 radians. All right, on to next example. Theta is negative 2 pi over 3. So this one's going to be kind of interesting. So when we're going around our circle, this is 0. This is pi over 2. This is pi. 3 pi over 2, all the way back to 2 pi if we made one complete 360 loop. So we're going to go 2 pi over 3, but we're going to go negative. So that means this is going to be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi would get us all the way back to here. So we're going the opposite direction. So we start here at our initial side, and we want to go negative 2 pi over 3. Well, if we went negative 2 pi over 2, that would be all the way to here. But we're not going quite that far. We're going negative 2 pi over 3, which is a smaller amount. So we'll start here. If we went, we're going negative 2 pi over 3. If we went negative 3 pi over 3, that would just be negative pi. But we're not going quite that far. That would be all the way to here. So we're going just to here. So here is our theta, negative 2 pi over 3. But we need to know this angle. It's the positive angle with the x-axis and the terminal side. Now, if we had gone 3 pi over 3, we would have landed here, right? But we only went 2 pi over 3. So we were short 1 pi over 3. We went 2 pi over 3s. If we'd gone 1 more pi over 3, we would have been to 3 pi over 3, which would get us to pi. Now, it said that the reference angle is always positive. So I know that negative pi over 3 is what would add to this to get us all the way there, but we're always going to use the positive. So theta prime is pi over 3. All right, and we're going to skip these. Don't worry about these right now. Just focus on what you got, and we'll see you tomorrow.